When we think about building an artificial mind today, we usually picture massive data centers. We assume that if we just stack enough processing power and enough servers together, intelligence will eventually spark into existence. But AI pioneer John McCarthy saw these massive physical machines as a distraction. He realized that human-level intelligence was blocked by conceptual puzzles rather than a shortage of raw electronic speed. For thousands of years, philosophers debated the abstract essence of knowledge, belief, and truth. They built incredibly complex theories, but those theories rarely had to survive contact with physical reality. McCarthy introduced the designer stance. As an engineer, he stopped pondering the metaphysical nature of thought and began identifying the exact ingredients and rules required to make a machine physically act intelligent. To build a thinking system, engineers stripped away romanticized notions of the mind. They adopted an extreme pragmatism, forcing centuries of abstract human philosophy into strict functional code. McCarthy laid out 4 strict rules, hypotheses a machine requires to establish an objective baseline of reality. He considered these the non-negotiable foundation of logical AI. This split-screen model illustrates the rules. First, an objective world exists independent of the robot's circuits. Second, its beliefs must align with that reality. Third, it must instantly translate raw visual appearance, like a chessboard, into a clean algebraic grid to plot its next move. Finally, McCarthy argued for a strict literal analogy. The mind is simply the software running on the physical hardware of the brain. This software framework directly challenges classic arguments against AI, like John Searle's famous Chinese room thought experiment, which claimed machines only blindly manipulate symbols without ever truly understanding them. McCarthy argued that critics were looking at the wrong scale. True comprehension belongs to the entire interconnected system working together, rather than a single central processor or rulebook. These 4 rules create a highly rational architecture for thought, but place that pristine logical architecture into the messy, unpredictable outside world, and it immediately runs into a massive problem. Early AI systems could diagnose complex blood diseases with incredible accuracy, yet they would fail completely at figuring out how to cross a busy street. This happened because those machines operated inside closed worlds. In a controlled environment, like a chessboard, the rules are perfect, rigid, and unchanging. Historically, this is where AI thrives. But human reality is an open world. We operate using concepts that are entirely fuzzy. Ideas like justice, concepts of love, or what qualifies as a chair. When a rigid logical system encounters these ill-defined variables, it freezes up. This logic tree demonstrates McCarthy's first structural solution, non-monotonic reasoning. This is the mathematical ability to draw a conclusion by default and then completely reverse it when contradictory evidence arrives, without crashing the whole program. If the system knows birds fly and Tweety is a bird, it assumes Tweety flies. If it learns Tweety is a penguin, it seamlessly updates that specific conclusion while keeping the rest intact. Without this updating logic, systems fail spectacularly. The physicist Lord Kelvin severely miscalculated the age of the Earth because his initial math relied on a default assumption, the absence of radioactivity, that he never revised once new science emerged. To survive the real world, an artificial mind also needs what McCarthy called elaboration tolerance. If you're walking through a supermarket and suddenly remember you have a flight to catch, you instantly drop your grocery plan and pivot your goals. A truly intelligent machine must adapt to sudden, unrelated variables just as smoothly. What we casually call common sense is the mechanical capacity to tolerate unexpected elaborations and rewrite assumptions on the fly. By forcing these ancient philosophical ideas into rigid engineering structures, we actually begin to demystify our own minds. Take the debate over free will. This branching diagram shows how McCarthy reduced it down to a functional 2-step process. First, the system consciously calculates an expanding tree of possibilities. Then, it deterministically executes the mathematically optimal path. The sensation of choice is simply the awareness of that first calculating phase. This pan across modern server racks represents the brute force processing power we rely on today. We have largely moved away from McCarthy's pure, logic-based architecture to embrace large language models. These models process massive amounts of data to statistically predict the next word in a sentence, convincingly mimicking common sense. But because they lack McCarthy's foundational logic rules, they frequently hallucinate, confidently presenting absolute nonsense as fact. The final, unmet challenge is context. Genuine intelligence requires a virtuoso capacity to jump seamlessly between an infinity of implicit realities, switching from game mechanics to conversational subtext without losing the thread. Ultimately, the pursuit of artificial intelligence serves as a mirror. Constructing a digital mind demands that we finally provide a concrete definition for human reason and the nature of